let's take a look at how you're going to solve some of the questions on your first homework assignment. So we see here on Monday that the first 4 questions ask you to translate the following verbal expressions into a mathematical sentence. So that means that we want to take all of this English words and turn them into an algebraic sentence or expression. So here we read for more than a number W. So you have to recognize the operation that is equivalent to more than, and that would be addition. Now technically the word than is a backwards translation. So if I have 4 more than W, I can't add 4 unless I know what W is first. So W plus 4 is the actual correct direct translation of the sentence. But since the operation of addition is commutative, 4 plus W would be considered correct. But this one is the best answer. 2 less than twice a number. Less than is our operation. And like I said earlier, the word than requires a backwards translation. If I have 2 less than you, I can't find out how much I have unless I know how much you have first. So 2 less than has to come after twice a number n. So twice means to multiply by 2. So twice a number n, and I have 2 less than that. Subtraction is not a commutative property. This is the one and only answer to this question. The quotient of a number a and 5. So a quotient is division. You can show it using this symbol, or you can show it using a fraction bar as the division symbol. Both of those answers are correct. This is preferred. The product of 3 and the sum of the quantity are and 9. So when I use the word quantity here, that means a group of items. So the product of 3 and the sum of the quantity R and 9 means that the sum is only for R and 9, and they are in a quantity. And the product of 3 and that sum means I'm going to multiply 3 times that quantity. I'm going to use an invisible implied multiplication symbol here with the parentheses. Right, second part of the first assignment is to determine which quadrant each point lies in. So a quadrant is a quarter of a coordinate graph. So let's take a look here at our coordinate graph. The quadrants are labeled using Roman numerals 1, 2, 3, and 4, and they go in a clockwise order. So I didn't ask you to plot these numbers, but simply to determine the quadrant in which the point would lie. So for question number 5, if I need to go to the location of -5 and -6, then I would simply move in the direction from the origin, which would be negative on the x value, this way, and negative on the y value, this way. So the exact point would be at -5, -6, which would be here in quadrant 3. So the answer is Roman numeral 3. If I were to move along the x-axis to 2 and the y-axis down to -4, the next point would be located in quadrant 4. Now I deliberately gave you really large numbers for this next question because I don't actually want you finding the location, but just understanding the direction of the signs. So a negative x value is to the left and a positive y value would be up. So somewhere here in this second quadrant would be this really high value point. Number 8, fractional numbers. Again, you don't have to plot the exact number, you merely have to move in the correct direction of the signs of these values. So a positive x value and a positive y value. This point would be located in quadrant 1. For Tuesday's assignment, I actually ask you to graph the points. So here's an example of a couple. I'm not going to do all of them, but I will do number 9, number 12, number 13, and number 14. So not only do you need to graph the coordinates, but you need to label it with the correct letter. So for question number 9, I'm going to plot -2 on my x-axis and -1 on my y-axis. X-axis is left to right, so I'm going to move -2 on my x-axis and then down -1 on my y, and I'm going to label that A. Now I'm going to skip 10 and 11, and I'm going to go down to number 12. 0 on my x-axis means I will move no boxes left or right. And +4 on my y-axis means from the origin, I will simply move up to +4. And I'm going to label that B. Question 13 asks us to move -3 on our x-axis and nowhere on our y-axis. So from the origin, 3 in the negative direction would be here. And nowhere on my y means I stay right on that axis. I'm going to label that E. And now for the last point. 2 on my x-axis and +4.5 on my y. So from the origin, I'm going to move x first, 2 to the right, and then 4.5 on my y. Up 1, up 2, up 3, up 4, and then halfway up. And I'm going to label that F. That's how you graph points on the coordinate plane. Now for Wednesday's assignment. You can certainly use a calculator for this, but I'm going to show you the basic steps. If there are any parentheses, you distribute first. If there's more than one term that can be combined, you combine second. Third, you add or subtract. And fourth, you multiply or divide. So I see no parentheses on question 15. I look at the left side of my problem. There are two values here, two terms, and they are not like terms. Therefore, I cannot combine them. My right side has only one value, so there's nothing to combine. So now I'm going to move my constant here of -4 by adding 4 once to each side of the equation. That eliminates the constant from the left, leaving me with a 2x, and my new solution is 14. This is a coefficient, and coefficients multiply variables. So to undo multiplication, I'm going to use division. 2 is the number I want to eliminate, so I can cancel my coefficient here by reducing 2 over 2 to an invisible 1x. My new solution is 7. Let's try another one. There are no parentheses, and there are no terms to combine. So I'm going to remove my constant first, rewrite my equation with my new solution. Clear my constant by using the opposite of multiplication, which is division. Make sure you use the exact number as is, -4, -4. X is equal to -2. Number 17 is the same exact type of problem as 15 and 16, but the constant and the coefficient terms are in a different order. The positive sign here belongs to the 6. So the sign that belongs to 3 is an invisible positive just to the left. So to clear my constant, I do the opposite of 3. And then to clear my coefficient, I'm going to use division. Let's try a few more. Number 18 has parentheses. This requires me to multiply the 2 on the outside by every term on the inside, but nothing past the parentheses. Now I'm going to solve it just as I did the previous 3. Clear my constant, then clear my coefficient. Number 19. Remember what I said before over here on question 17? The plus sign belongs to 6? Well, this minus sign belongs to the 4. So the 6 here actually has an invisible positive sign in front of it. So to clear this constant, I'm actually going to use a minus 6. But be careful to bring down the minus with the 4. Divide by your exact coefficient, which is negative 4, and watch your signs. The last question here also requires some distributing. 3 times x is 3x. 3 times 4 is 12. I'm going to clear this constant by subtracting 12. 2 negatives means I have more negatives. And now I'm going to divide by my coefficient. Now I'm going to clear this screen, and I'm going to show you one more question that doesn't come out to be a perfect integer answer. So here's an example. 2x plus 7 equals 10. Clear your constant. Clear your coefficient. And then determine if you cannot actually divide 3 by 2, you have 2 choices. You can leave the statement as is and say that x is equal to 3 divided by 2, or if the division comes out to be a terminating decimal, that means a decimal that ends and does not repeat, you can convert it to a decimal. So 3 divided by 2 is 1.5, and that is a terminating decimal. It doesn't go on forever and ever and ever. So you can write it as a decimal. All right, now for the Thursday box. How to construct and label a linear graph from the data table. Well, first you have to know what you're going to be graphing. Number of apples, and then the cost of all of those apples. So we're going to label our axes first. So here we're going to put on our x-axis the number of apples. And then on our y-axis, we're going to put the cost. Now the first thing I'm going to do is show you a very common mistake. I see it every year and it's wrong. Students take a look at the values in the chart and they really just start copying things like this. 2, 4, 10, 14. And this is not accurate. Those are the numbers in the table, but a graph cannot have a representation of 2, 2, then 6. This is worth 2, this is worth 2 more, but this box is worth 6 more, and that doesn't make sense. It has to have what we call a consistent scale. So if this is going to be worth 2, all of the boxes have to be worth 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, etc. Again, these are our number of apples. And now we have to look over at our table to find out what scale we want to use to represent the cost. So the whole graph represents the cost of apples. And this axis here seems like it's going by quarters, by 25 cents. So I can put 25 cents here, whoops, 50 cents here, 75, $1, 125, 150, 175, $2, etc., etc. So now we need to graph these data points. So it looks as though 2 apples are 25 cents. So 2 apples, 25 cents. 4 apples, 50 cents. 10 apples, $1.25. So I'm going to go over to 10 and then up to $1.25. And 14 apples is $1.75. And it did say that I was going to construct and label a linear graph, which is a graph that is a straight line. And it appears as though my data has come out straight. So I got to make sure that this goes all the way to the origin, but I can't draw it past here because there's no such thing as negative apples and negative money. But I am going to draw an arrow up here because if I wanted to, I could buy more apples. And the cost would keep increasing. The more apples you buy, the more money it costs. So when we describe this, we would say, as the number of apples increase, the cost also increases. And that's how you would solve your first homework assignment of the year. If you still have more questions, be sure to come to Extra Help.